Hey everyone, and welcome to The Explainer. Today, we're diving into two absolute titans of the data world, Snowflake and Azure Data Factory. But we're not just going to talk theory here. This is a practical, hands-on guide to making them work together and work together beautifully. So let's get right into it.
So when you first look at these two platforms, you'd be forgiven for thinking they're competitors, right? On one side, you've got Snowflake, which is just a beast when it comes to high-performance analytics, mainly because of its incredible architecture that separates storage and compute. Then on the other side, you have Azure Data Factory, or ADF, which is the absolute master of orchestrating complex data pipelines, and it's plugged into the entire Azure ecosystem. They both play in the data space, but their real superpowers are actually pretty different.
So instead of thinking versus, what if we started thinking and? What if you could have the best of both worlds? What happens when you use ADF's incredible orchestration power to feed Snowflake's world-class analytics engine? Well, that's when things start to get really powerful. To show you how, here's the game plan for today. First, we'll talk about why there's such a power couple. Then we'll get into the real nuts and bolts, making a secure connection, mastering those tricky incremental loads, and answering the all-important pushdown question. And finally, we'll wrap up with how to troubleshoot some common errors you might run into.
All right, first up, let's establish why these two are truly a data power couple. It really all boils down to how their strengths complement each other perfectly.
And here's the key thing to get your head around. They aren't doing the same job. Just think of Azure Data Factory as the brilliant conductor of a massive orchestra. It's not playing an instrument, it's managing the timing, the flow, and the movement of data from all these different sources. Snowflake, then, is the world-class orchestra itself, a specialized high-performance engine built to take all that data and just make magic happen with it. One conducts, the other performs. Okay, so we know why they work well together. Now let's get practical and actually build that partnership. A solid, secure connection is step one, and we're going to focus on a really robust method, key pair authentication. Now, you can break this down into four pretty clear steps. First off, you've got to set up what's called a self-hosted integration runtime. Basically, it's a secure gateway you control. Second, you configure the actual key pair on your Snowflake user account. Third, you install the Snowflake ODBC driver onto that runtime machine. And finally, and this is the most important part, you configure the connection, the DSN, to use the Snowflake JWT authenticator. That little setting is what tells the driver to use your private key, making the whole thing super secure.
All right, connection's solid. Now let's tackle something that trips up so many people: incremental loads. How do you efficiently handle not just the brand new records, but also all the records that have been updated back at the source?
And this isn't some theoretical problem. Check out this post from a developer, Coder1990, on Stack Overflow. They laid out the exact challenge perfectly. Their pipeline was awesome at adding new rows, but it was completely blind to any changes made to existing ones. This is such a classic problem when you're trying to keep a data warehouse in sync.
Luckily, the solution has a name, and it's a great one: upsert. It's literally a mashup of update and insert. An upsert is a smart operation. It looks at a row and asks, "Hey, have I seen you before?" If the answer is yes, it updates it. If no, it inserts it as a new one. It's exactly what Coder1990 needed.
And here's how you actually build this inside an ADF data flow. Step one, you might add a derived column for things like modification dates. Step two, you use an alter row transformation. This is where you set the rules, telling ADF what makes a row an upsert row. Step three is pretty much the magic button. You go into your Snowflake sync settings and just check the box that says Allow Upsert. And finally, step four, you have to tell Snowflake which column is the unique key so it knows how to find those existing records. You do those four things, and your pipeline is now handling inserts and updates like a champ.
Okay, this next one is a huge deal. It's a question that seriously impacts performance, cost, the whole 9 yards. When you're building all these transformations in ADF, where does the heavy lifting actually happen? This is the pushdown question.
And this question from a user named Nars on the Microsoft forums just nails it. Is ADF pulling tons of data out of Snowflake, doing all the work on Azure servers, and then shoving it all back in? Or is it smart enough to push down that work, telling Snowflake's powerful engine to do it instead?
Well, here we go. The definitive answer from Linda Wang at Microsoft. And the answer is, it's kind of a hybrid. So your transformations in the middle of the flow, like joins and filters, those happen on ADF's own runtime. But
And this is the critical part. The final commands to write the data, the insert, update, upsert, or delete, those are pushed down and run natively inside the Snowflake engine. And understanding that difference is absolutely key to designing efficient pipelines.
All right, but let's be real. Things don't always go perfectly the first time, right? So no implementation guide would be complete without talking about what to do when things go wrong. Let's look at some of the most frequent hurdles you might face. So if your connection is failing, chances are it's one of these 4 usual suspects. It could be a simple firewall problem, your IP isn't on Snowflake's allowed list. It could be a permissions issue on your storage account. A really common one is messing up the shared access signature, or SAS token. Or if you're using a managed VNet, its address range might be blocked by a Snowflake network policy.
Let's just zoom in on one of these, the dreaded 403 authorization failure. If you see this, it almost always means one thing. The SAS token you gave Snowflake to access your Azure Blob storage is missing some key permissions. You have to make sure that token allows Snowflake to not just read and write, but also to list the files in that container.
And that brings us to one last thought to chew on. We've just walked through how these two incredibly powerful tools can be wired together. And as they and other tools like them integrate more and more seamlessly, it really makes you wonder, right? Is the future of data engineering going to be less about the tedious work of building every single step of a pipeline and more about just defining the business outcome you want and letting the tools figure out how to get there? It's a pretty exciting thought.